Assalamualaikum. Hi everyone. Today our new topic is transformer. Transformer is an electrical device which is used to transfer the energy between two or more circuits through the electromagnetic induction. So now we go to the basic of the transformer first. Basically, the transformer consists of two windings which are wound on the same core. We have a primary windings and a secondary winding. The primary winding is always connected to the power source, which is basically AC, and the secondary winding is always connected to the load or the output. And the core provides a physical structure for the placement of the windings and also provides a magnetic path so that the magnetic flux lines are concentrated close to the coils. A typical core material used are air, ferrite, and iron. And air and ferrite cores are always used for the high frequency type of transformer, and the iron cores are always used for the low frequency type of transformers and power applications. And core always must be laminated just to reduce the eddy current losses, and it also have a high permeability to increase the lines of flux and to reduce the flux loss during the operation of the transformer. Okay, now we go to the structure of the transformer here. Okay, so this is a core. It is laminated, and this core has two limbs here. The primary winding is on the one limb, and the other winding is on the second limb. So the primary winding is connected to the AC input voltage, and the secondary winding is connected to the loads. Um, these two windings are not directly connected. Okay, they just connected through this core. Okay, so we have a mutual induction. Okay, between these two windings, just to transfer the energy from the primary circuit into the secondary circuit. Okay. So we have a different types of transformer has been invented. Okay, we have a power transformer, and here is the current transformer. Okay, used. This is used to measure the amount of current flow through this power conductor. And normally, it is connected to the ammeter just to show how much current flow into this conductor. Okay, okay, turns ratio. Okay, turns ratio is defined as the ratio of the number of turns in the secondary winding to the number of turns in the primary winding. So in another word, N is equals to secondary number of turns over primary number of turns. Okay, so this will define the output voltage of the transformer by using this transformation ratio. Okay, meaning that we can find the output voltage of the transformer by using the turns ratio. Okay, and this is a relationship between the voltage input and output with the turns ratio. Secondary voltage is equals to turns ratio times primary voltage. So from here you can find the output voltage. So I give you one example here. This is a transformer with input voltage of 230 volts AC and a 100 number of turns on the primary and 1000 number of turns on the secondary. So from here, by using the turns ratio or the transformation ratio, you can have 2300 volt AC on the secondary of this transformer. Okay, so this shows you that the output voltage here is higher than the input voltage by 10, and this is a step-up transformer. Okay, step-up transformer is a transformer which increase the output voltage by turns ratio. Okay, and the turns ratio must be always more than 1. And I give you another example here. Right, this is a transformer with 230 volt AC as the input voltage, 100 number of turns on the primary, and 10 number of turns on the secondary. So from here you will have 1 over 10 or 0.1 turns ratio, and this give you 23 volt AC as the output voltage. So meaning that this is a step down transformer which um, stepping down the input voltage into a lower value by 10 times. Okay, so um, the step down transformer has a turns ratio which is always less than 1. Not only the turns ratio define the output of the transformer, the direction of winding also define the output of the transformer in terms of the polarity. Okay, the direction of the winding determines the polarity of the voltage across the secondary winding with respect to the voltage across the primary winding. This is because of the direction of winding between the primary and the secondary. So this will give you uh, either the in-phase output voltage or out of phase of output voltage. Um, the first figure shows you the phase dots. Okay, the phase dot is the indication to show that the polarity for the input and output. So this phase dot um, are located on the same position for both primary and secondary winding. So this shows you we have the in-phase output voltage with the um, input voltage. While the other figure show you um, the primary winding has the phase dots on top of it, and the secondary winding has the phase dot at the bottom of it. So this will give you the output voltage, which is out of phase with respect to the primary voltage. Okay. So this again, okay, this is schematic diagram of the transformer with the phase dots indicate the voltage are in phase, and the second figure shows you the phase dots position indicates the secondary voltage is uh, out of phase with respect to the primary voltage. Now we go to the step-up transformer. Okay, a transformer in which the secondary voltage is greater than the primary voltage is called a step-up transformer. Okay, so and the step-up transformer has a turns ratio which is greater than 1. So again, we can use the turns ratio or the relationship between the voltage ratio and turns ratio to find whether the transformer is step up or step down. Okay, and the step down transformer in which the secondary voltage is less than the primary voltage and the turns ratio is always less than 1. At the end of this topic, I will give you questions or the exercise for you to apply this formula to find the output voltage of the step up and the step down transformer. Um, we don't have a very ideal transformer in this world because we may have a losses during the operation of the transformer. Okay, we have a few type of losses in the transformer. Okay, uh, there are two losses in transformer. We have iron losses and also the copper losses. Okay, iron losses is divided into two. We have eddy current losses and hysteresis. And copper losses is about the resistive losses, which is in the wire itself. Okay, which is I square R. Okay, eddy current is a small voltage produced by heat. To minimize heat uh, is by eliminating the iron core. Okay, so this is how we reduce the eddy current losses. The iron must be eliminated, meaning that the iron core is made of a very thin layer of iron, which are piled together and become one block of core. Okay, just to reduce the eddy current, which are always uh, produced on the surface of the core. Hysteresis losses is about the um, magnetization and demagnetization of the material when you have the energization from the electrical power. So it depends on type of material. Either you will have a bigger hysteresis loops or a narrow hysteresis loop. Okay, so normally the iron core or the soft iron core will give a better hysteresis or very low hysteresis losses for the transformer. And we may also have resistive losses in the winding, okay, power loss due to the resistive conductor. And somehow we also have the flux linkage losses um, on the core of the transformer. So these are all the losses that we have in the transformer, meaning that we don't have an ideal transformer in this real world. That's all for today. So thank you for your attention. Make sure you understand the transformer, and after this I will give you a quiz for the transformer. Thanks for your attention.